Okay, so we're going to solve this differential equation. So let's isolate for, sorry, let's have everything in terms of dy over dx plus p of x y plus equals f of x. Okay, so what we're going to do is divide everything by x. And notice there's something wrong here. So we have p of x, so that's good. But look at f of x. This is not good because of this y squared. If this y squared wasn't here, then f of x would just be x. But we can't set f of x to be xy squared. Okay, that's the problem. So what we're going to do is use Bernoulli's rule. So Bernoulli's rule is pretty much set u to be equal to y to the power of 1 minus n being this power. So it'll be 1 minus 2. So u will be equal to y minus 1. Now we differentiate for u. Alright, so there we go. Now the next thing we're going to do is isolate for this and then plug it into here. So dy over dx is going to be equal to minus 1 over xy plus xy squared. So plug all of that into here. Okay, now let's FOIL that minus y to the power of minus 2 in. So that should be the following. Yeah, okay, because minus y to the power of minus 2 times y squared, though minus 2 plus 2, that's 0, so it's y to the power of 0, so that's just 1. So now we're left with this. Now let's get rid of, recall, u is equal to y to the power of minus 1. Now let's bring that to the other side. And look at that. That more matches this equation. So this is du over dx is equal to plus p of x times u equals f of x. So p of x is equal to minus 1 over x, and f of x is equal to minus x. So we're going to use the following formula. But instead of y, we're going to use u. And then plug in p of x and f of x into everything. So let's take out the negative from here, and so same goes for here. So that's just minus ln of x plus c. And the same thing goes for here. That's just minus ln of x plus c times minus x. And that's the same thing as e minus ln of x times e to the power of c. And now we're going to integrate both sides with respect to d of x. So this and this cancels each other out. So now we have e minus ln of x times ec times u equals the integral of e minus ln of x times ec times minus x dx. We're going to take out this ec and put it here. So this and this cancels each other out. And then we're going to take this to be the power of minus 1. So the lns cancel each other out. So now we have x to the power of minus 1 times u equals the integral of x to the minus 1 times minus x dx. We're going to take the minus out, so that's a constant. So this and this also cancel each other out. And this will just be equal to the integral of dx. That's going to be x plus c1. And now we just divide everything by x minus 1. So that's u equals minus x squared plus xc1. Okay? And now we just have to have everything in terms of y. So recall u was equal to y minus 1. So u was equal to u was equal to y minus 1. Okay? So that means if we uh, times this by minus 1, then we also have to times this by minus 1 as well. So this and this cancels out. So u minus 1 is equal to y. So take this to the power of minus 1. Okay? And now you solve for y.